What we're going to do is we're going to look at how we can analyze circuits to be able to assign the voltage, potential, current, and resistance to each of the resistors or to the overall circuit. Now, just a couple of terms, making sure that we understand this. So circuit is a closed loop. We can have more than one branch. Nodes are where wires join. Okay. Now, when we analyze this, we're going to use Kirchhoff's law. He has laws for both voltage and current. And what we're going to do is we're going to use these ideas to be able to analyze them. And he has separate laws for current and voltage, and they depend on the type of circuit. And the laws differ for each of the circuit types. So if we were to take a look at a circuit in series or loads that are in series, what we know is that loads that are in series will all have the same current. And this is because since current is a measure of the charge per unit time or number of electrons per unit time, and there's only one path for all the electrons to go through, they'll go through each of the loads. So therefore, when loads are in series with each other, they have the same current. However, when loads or objects are in series with each other, their potential difference must be shared because they have a potential difference or voltage that they're given the power source, and it gets used up by the loads. And so therefore it's shared amongst the loads that are in series. So let's take a look an example here where we have two resistors that are connected to a power source. One of our resistors is a 10 ohm resistor and the other is a 40 ohm resistor, and we want to know the current throughout it, we want to know our current at each, and the potential difference for each as well as our total resistance. Now, one of the first things that we always do when we are doing an analysis of the circuits and we want to assign values to the different loads or features in it is that we want to write down our givens, and we want to label each of our entities in the circuit with the values that we know. So here what we've done is we've labeled the values for the load, or what the values are overall, so our overall resistance, the potential difference at the power source, and also we're going to look at the current that comes out of our power source. And then we have for our first resistor, which will give a resistance of 10 ohms, its potential difference and its current, and finally also our second resistor with its resistance, and then we'll determine these values. Now, because these are in series with each other, and Kirchhoff's law tells us that objects that are in series have the same current, what this tells us is that the current that comes out of the power source and goes through, all the electrons are going to go through each resistor. So as a result, each of the currents are going to have the same current as what comes out of our power source. Additionally, they're going to have 150 volts when they come out, and 150 volts has to be consumed by the loads before they return. So therefore that 150 volts is going to be shared between this resistor and this resistor. And finally, because of the manipulation of this equation and V equals IR, what that allows us to do is it allows us to know that my total resistance is equal to the sum of the resistance of each of them. And again, this is just Ohm's law. So as a result, the first thing we can calculate is our total resistance. Since we don't know our initial current, knowing the total resistance will allow us to determine that. And it's just equal to the sum of the resistance of the two loads that are in series with each other. Then what we can do is we can use this to determine my overall current, because it's the potential difference at the power source divided by the total resistance will give me my current. Now that I know the current that comes out of my power source, this allows me to know the current for each of the loads. Once I know that, I can use Ohm's law to determine the potential difference of my first resistor and the potential difference of my second resistor. And we can mentally see 150 volts are supplied. The first resistor is going to use 30. The second is going to use 120 volts. And we can see that those add up to 150.